Hi, this video is about how to figure out an empirical formula and then figure out a molecular formula from that. This question corresponds to your worksheet that's called Empirical and Molecular Worksheet, and then it is number 5. So in the question they're telling me that I have a compound that has a molar mass of 34. That means that's the real molecular formula of the substance and its molar mass. They're giving me the grams of the elements that are in the compound. So sometimes I'm given percentages and then I have to assume a 100 gram sample. This time I don't. So whenever I'm doing this type of problem, I have to figure out the empirical formula first, which means that I need to take the grams and calculate moles of the elements first. So 1 mole of hydrogen has a mass of 1.008 grams. So then hold on one second. So when I'm converting the grams of hydrogen into moles of hydrogen, when I write my answer here, I'm not really worried about sig figs. I am really interested in going out quite a few decimal places because eventually we're going to try to divide and get whole numbers, and it's easier if you go out more decimal places. So my grams of oxygen, I'm going to convert that using the molar mass of oxygen. And then I have my moles of oxygen. So you can see that these are about equal. But the next step that we would do is we would divide both of these by the smallest number. So I would want to take my moles of hydrogen, divided by 0.4325. So that means I'm going to have 1 mole of hydrogen in my empirical. And then for my oxygen, you can see that I'm also going to have 1 mole of oxygen. So my empirical formula is going to be HO. You don't have to worry about order, but the one with the lower electronegativity goes first. And then what I want to do is I have to figure out the molar mass of this empirical formula. And I'm going to compare that to the molar mass of the molecular formula. So when I do this, hydrogen is 1.008, and then the oxygen is 16. So I get 17,008. That's the molar mass of the empirical formula. If I look in the question, this will always be given. I have the mass of the actual molecule or the molecular formula. So I'm going to calculate N, which is looking at those two. So I'm going to take the molar mass of the molecular formula divided by the molar mass of the empirical. And when I do that, it's 34 divided by 17 essentially, which is 2. So in reality, the real molecular formula is going to be the empirical formula times 2, which would then be H2O2. So to review, I took my grams. If I hadn't been given grams, I would have had percentages, assumed a 100 gram sample, calculate moles, divide by the smallest moles so that I can figure out my empirical formula, figure out the molar mass of the empirical, see how that compares to the molar mass of the real molecule or the molecular formula. Whatever I get here is how many times greater the empirical is compared to the molecular is compared to the empirical.